Okay, YouTube, in this last video on inverse functions that I'm doing here, I'm going to comment on the nature of the graphs of a function and the graph of its inverse function. And so the number one point we're going to kind of draw upon here when we talk about the relationship between the graph of, say, f and some f inverse here is the fact that the domains and ranges of inverse functions have just switched, okay? So that is to say that for every point a, b on the graph of f, now I'm going to stop here in this sentence, and I'm going to look on the right side here. The graph of f is this blue one right here that looks like half of a sideways parabola opening upward, but you notice at this point AB is on the graph here. We know that because domain and range switch for inverse functions, then we say that the point BA is on the graph of f inverse. And so you can see that BA is actually over here on this graph. So instead of going right A and up B, we're going right B and up A. The reason why this is significant is because it causes our graphs to be reflections about this line y equals x here. And this is always going to be true with inverse functions because of the fact that their domains and ranges switch. So what is true about inverse functions is that the graphs of f and f inverse, if f inverse exists, are reflections about the line y equals x. And just to be clear on this, y equals x, this is just some slope-intercept form of a line which has a y-intercept of 0 and a slope of 1. So that being said, what I want to do is I want to consider this graph down here, and we say consider that it's f of x. We have some y equals f of x as shown. What we want to do is use the reflection property to easily sketch its inverse and then comment on the domain or range of f and f inverse respectively. So before we begin this and find the inverse of this, what I'm actually going to do is I'm going to find the domain and the range, and I want to switch my color here. We'll do the original graph in blue and in blue. So we say the domain and range of this graph. And so I noticed that on the x-axis that it has a domain of -3 out to +4. That would be our domain. We're including both of those points. So domain is -3 up to and including 4. And then its range starts down at -2, and then it proceeds to go up to a height of 2 on the y-axis here. So we would say from -2 to 2 is our range of values for this function f. So this is true for f. We'll do our next one here, f inverse, in this pinkish color. So in order to sketch its inverse, this is not something that we have to do, but I am going to do. I'm going to draw on this line y equals x to kind of help me visualize this, but I know that it has to be a reflection about this line y equals x, our inverse function does. What I'm really going to do, though, is grab all of the key points on this graph, and I'm just going to switch their values around. That is to say that the point 4, 2 is on our original function. Then if we switch the domain and range, then the point 2, 1, 2, 3, 4 is now on our inverse function. So you can see how this popped over this line right here, y equals x. Likewise, -1, 0 is going to become 0, -1. So 0, -1 would just be down 1 from the origin. It'd be this point right here. And then we also could see that -3, -2 would become -2 and then down 3, and that would be this point right here. So in order to sketch the inverse, all I'm going to do is I'm just going to connect the dots here, sketch this across. But you can see how these two graphs are just reflections of one another over this line y equals x, and this is going to be true for any set of inverse functions. So before we move on here, we have our domain and range of the inverse function. We could take a look at the inverse now. The inverse, its domain starts at -2 and goes out to +2. And I'm hoping that you're recognizing here that this -2 to +2 inclusive is the same as the range on the original function. When we look at the range of the inverse function, which starts down at -3 and goes up to +4, we can see that that range right there from -3 to 4 inclusive is the same as the domain of the original relationship here. And that's one really important key characteristic we want to try to point out here. So for this last part of this video here, what we're going to look at, if I can click on it here, is this. It says the graph of a function f consists of two line segments. One segment from -2 to 2, -2, 2 to -1, 0. So we're going to go left 2, down 2. It starts at this point here. Let me see if I can click on this so we can draw on it. So left 2, down 2 is going to be this point right here, and I should label this. But we say from there to -1, 0. So here's one line segment on our graph, and this is -2, 2, -2, that is. And then we would say that this is the point -1, 0. And we say a second segment from -1, 0 to +1, +2. So right 1 up 2. So this is the other part of our function here, and it goes to 1, 2. So we say graph f and use the graph to draw and the graph of its inverse function. So we've graphed f here. What we're going to do now, without drawing that line y equals x, is we're going to switch the points on this graph around and draw the inverse. So we say 1, 2 would become 2, 1. So we're going to go right 2, up 1. -1, 0, we have observed before, becomes 0, -1, which will be this point right here. And then the interesting thing with -2, -2 is it actually lies on that line y equals x. And so we'll observe that when we switch -2 and -2 around, we still get -2, -2, which is on the inverse. We would say its inverse function looks like this right here, and we could see that reflection across that axis. So I'm going to label this f inverse, whereas this graph right here I'm going to label f. So no need to comment on the domain and range of these two, but I would encourage you to look at that to see that the domains and ranges have switched. Cheers.